New from explosion.
The measurements: 1.7 meters high, 6.56 meters long, a thrilling experience lasting 3.51 seconds, with an average speed of 1.87 meters per second. That can increase to a heart-pounding speed of
2 meters per second.
You may start off slow at a speed of 0.13 meters per second halfway down the first descent, creating suspense until the top of the first loop where you will reach a speed of 0.2 meters per second. Then at the top of the hill, you will reach a speed of 0.29 meters per second.
To find average time, you add up all the times you took, which are 3.5 plus 3.3 plus 3.5 plus 3.7 plus 3.6 plus 3.5, which equals 21.1. Then you divide it by the number of times you took, which was 6. So 21.1 divided by 6 is 3.51 seconds.
To find the average speed, we use the formula velocity equals distance over time. Because we're finding the average speed, we use the average time, 3.51, and we divide the distance, 6.566 by 3.51. And we get approximately 1.87 meters per second.
To find the speed halfway down the first descent, you will use the formula velocity equals distance over time. For distance, you'll want to use half of the distance down the first descent, which was 0.9, divided by 2, which would be 0.45. So you do 0.45 divided by 3.5, which equals 0.12 meters per second.
Find the maximum velocity, we use v equals d over t. And for distance, we use 6.566 meters, and for time, we use the minimum time because we want it to be going the fastest, so it's 3.3 seconds. So we get 1.9897 meters per second, or approximately 2 meters per second. To find the speed at the top of a hill, you're going to use velocity equals distance over time, and for the distance, you're going to use the height of the hill, so we divide 1.02 by our average time, 3.51 seconds, and we get approximately 0.27 meters per second. To find the speed at the top of a loop, you're going to use the formula velocity equals distance over time. Our distance is going to be the height of the loop, which was 0.71 meters. We're going to divide that by the average time, which is 3.51 seconds, and you get approximately 0.2 meters per second. To convert the mass of our marble, we use the conversion 1 gram equals 0.001 kilograms. So if our marble weighed 5 grams, our mass that we will use will be 0.005 kilograms.
To find the maximum kinetic energy, use the formula 1/2 times mass times velocity squared. To find the velocity, we use the square root of 2 times g times h, which once you plugged in the numbers equals 5.77234778. When we plugged it into our formula, it was 1/2 times 0.005 times 5.77234778 squared, which equals 0.0833 joules. To find the maximum potential energy, use the formula mass times gravity times height, and then you plug in 0.005 times 9.8 times 1.7, which gives you 0.0833 joules.
First, we start with maximum potential energy, and then while Purple is falling down the first descent, he is losing potential energy and gaining kinetic energy. Then while he is going up the loop, he is losing kinetic energy and gaining potential energy. After he starts going down, he loses potential energy and gains kinetic energy. When he goes through the curve, he is still losing potential energy and gaining kinetic energy. Going up the hill, he loses kinetic energy and gains potential energy. And then going down the hill, he loses potential energy and gains kinetic energy. Then going up the second loop, he gains potential energy and loses kinetic energy. And then going down the loop, he loses potential energy and gains kinetic energy.